I'm Brian DeLuca. I am at APEC 2026. I'm at the TDK booth with Annie Van Roy.
Hey Brian, how are you doing?
Good. How are you, Annie Van?
Not too
So
bad, not
we're
too bad.
hearing a lot about how solid-state transformers are impacting power electronics.
Yeah.
And what's the difference between solid-state transformers and traditional transformers?
Okay, so we are talking about traditional transformers. We know that the only thing it does is step up or step down
Hmm.
voltage at 50 or 60 hertz.
Okay.
Solid state transformers is a lot more than that. Why? Because it's not only a transformer, it's got the power electronics which it utilizes,
Hmm.
and that enables a solid state transformer to operate at higher frequencies, but also because of the power electronics involved, it can transfer medium voltage AC to low voltage DC, medium voltage DC to low voltage AC, and DC to DC. Plus, it also improves the power quality of the system. So when I say power quality, it means fluctuations, it means harmonics, and so on. So as you can see, it does a lot more than
More
a
of it.
standard transformer.
Annie Van, there's still some design challenges with SSTs.
Yep.
So what are some of the most difficult for engineers?
So the single most design challenge which SST manufacturers are facing at the moment is on the medium voltage high frequency transformer, because inside that, the design rule, as per design rule, you need to have 3 times the insulation voltage. So we
Okay.
are talking about 100 kilovolt of insulation. This is the challenge.
Okay. So what are the most expensive or most expensive parts in terms of the cost with this?
Okay, that's a very good question actually. Funnily, the medium voltage high frequency transformer is not the most expensive
Okay.
part. It contributes to about 15% of the SST cost. The most expensive is the power electronics.
Okay.
And this is where TDK plays. And
Okay.
that power electronics comes, it's about 40% of the total cost of the SST.
Okay.
So power electronics is the answer to that.
So what are some of the main industries or applications SSTs are being used for?
Right. So the biggest industry which SST is going into mass adoption
Okay.
is data centers.
Okay.
So this is coming in about, I would say, 2028, followed by EV charging stations. So this is the second biggest target market for SST. This is coming around between 30 and 31.
Okay.
And then it'll go to the renewable energies, which is post 32. So that's what SSTs.
Oh, and so
are
that's even the
aiming.
time frame for
That's
everything.
it. That's the
Okay.
time frame. This is. I'm giving you the complete answer
Yeah.
to this question.
Okay. We're also hearing a lot about high voltage systems becoming more common. Is 800 volt DC the only voltage for SSTs?
No, funnily, at the moment, only NVIDIA has specified the 800 volts,
Okay.
and likes of Microsoft and other companies are still talking about plus minus 400 volts.
Okay.
However, this is only the first generation of SSTs in terms of voltage, the
Okay.
high voltage, 800 volts. The next generation is going to be much more efficient, much higher voltage. When I say much higher, it's 1500 volts.
Oh,
so
okay. Wow.
nearly double.
So it's almost doubling.
And this is the second version. And the third version is the 2000 volt version. So this is where the photovoltaic market is already talking about.
Right.
So the higher the voltage, the lower is the current. The lower the current, the lower are the losses. That's what, because you're packing power density. We are all talking about power density within an SST. So the higher the power, if you don't hike the voltage, the losses are going to be quite a lot, because we are talking about I squared R losses.
Gotcha.
Yeah.
Is there a time frame for those other voltages?
I would say no,
Okay.
not yet. It depends on how quickly the industry moves.
Okay.
Because if I look at the Hopper chip for NVIDIA, it was talking about 40 kilowatts.
Okay.
The new Rubin Alto chip, that's already talking about 2,000 megawatts.
Okay.
So you see how quickly it's
yeah,
moving.
you can see a huge jump.
So the time frame could be quite quick, but
Okay.
at the moment everybody is talking about 800 volts.
Okay. So when architecture shifts like this, it also affects the components like protection, magnetics, capacitors.
Oh,
How
yeah.
is it all being affected by the change?
Oh yeah. So with SST technology, we are talking about wide band gap semiconductors. A shift from standard silicon. So that means we are talking about silicon carbide, we are talking about gallium nitride.
Hmm.
So when I look at silicon carbide application, that means high voltage, high current, high temperature
Right.
applications. What does it mean for components? I mean, luckily we
Hmm.
don't have the channels because TDK, for a long, long time in Americas and in Europe, more than 50% of the business was automotive.
Right.
So we are known for high reliable
Parts.
products.
Yeah.
So we don't have so much challenge. What is exciting is the fact that we are making more powerful components to meet the silicon carbide
Okay.
demand. And on the other hand, gallium nitride is quite different. Gallium nitride operates at high switching frequencies.
Hmm.
What does it mean for us? So you need smaller, yet more powerful, and components with low ESL, that
Okay.
is leakage inductance. So again, we are developing new products from our existing product family, and it's very exciting. It's not challenging at all for us.
Okay.
We are in a very good position because um, SST technology can take in cheap components.
Right.
Yeah. So they need high reliable products when we are so much in that space.
So are these some of the products you were talking about?
Yes, so this is only the tip of the iceberg here. So I'm going to show you some of the products which are used. So these are hockey puck ceramic capacitors which sit in the input side of SSTs for filtering purposes. And these are high voltage contactors. Again, this is a small version of a high voltage contactor. This is used for disconnect, current disconnect at the output side. And these are all, this is like a DC product.
Okay.
Then you've got the ferrites. So I don't know if you are aware, TDK was the first company to commercialize ferrites in this
Wow.
world.
Okay.
Way back in 1935.
Wow.
So these are the ferrites. Then we are talking about film capacitors. We are talking about aluminum electrolytic capacitors. We are talking about transformers. We are talking about multi-layer ceramic capacitors, the small chip bit. We are talking about temperature sensors. Then we are talking about protection devices. So protection can be for voltage, over voltage, and for current, and for lightning protection. So this is
Okay.
a massive over voltage. So we have surge arresters for that. So this is a huge range of components which we offer. By the by, you were asking for the cost of SST.
Yeah.
So passive components themselves, just passive component, contributes to 15%
Okay.
of the total cost of SST.
Wow.
In addition to the products which I just said, it's quite important in terms of our development on aluminum electrolytic capacitors, for example. These capacitors, do you see them taller and narrower? This is because it's going in a data center.
Oh, okay.
So these are the changes we are making at the moment because the aluminum electrolytic capacitors have to sit horizontally.
Okay.
So hence it needs to be thinner and longer.
I
So
gotcha.
these are the changes we are making, and this is a choke, and this is a whole range of magnetic products.
Well, Annie Ben, thank you for your time
Of
today. It was a
course.
pleasure.
Thank you. Thank you for talking to me.